Next is Wireshark. And what Wireshark is the world's most foremost and widely used network protocol analyzer. And what that basically means for us is the network captures. It's network capture software. It allows us to look into the data at a very granular level of what's going across the network. And there's, again, various reasons for it. It's used by researchers, government agencies, law enforcement uses it, pen testers use it, people doing security assessments. And of course, it's used in education. It's a great way to teach networking. So it's a free program. It has an extensive list of features. We can just go over a couple of them. Like I said, live capture, you see the data flowing. It's got browsers, it's got built-in viewers. If you capture images, you can see an image. If you capture sound, you can see this. You can play the sound. It runs on every imaginable platform available. So whatever your operating system is of choice, that's the one you can use. It can pick up voice over IP. It's got a lot of different features because it's community built. Thousands of people work on it. And so we'll go ahead and we'll take a quick look at how it works, and you can see what goes on with it and how we use it in our investigations. All right, we're going to go ahead and review Wireshark now. This is pretty basic introduction to it. Wireshark is a very popular software for network and data capturing. Sits on the network just listening for data and logging every packet that it sees coming across the network. Or come into your computer. Extremely popular piece of software. It's used by, it's the default used by everybody from, researchers and to network engineers and things like that. So it's definitely something that is known. It's not kind of a, abstract piece of software no one's heard of. Lots of resources available. The formatting is standard, so as it captures the data, it's you can export the data into many different applications and things like that. It uses what they call a PCAP format, and there's a couple of versions of PCAP, but they're all compatible. Again, like I said, there's a lot of training out there, a lot of resources. You want to read up on it, YouTube videos, things like that. There's conferences, as you can see from their homepage here. It basically, there's this thing called Shark Fest 19 here, it looks like. Everyone gets together and it's a conference on Wireshark. All right, so there's lots you can do with it. It's something you want to play with, learn. It's a lot of fun. It's really interesting to see what goes on. You basically go to the website, you download it, download the latest version of it, follow the default prompts. I'm not going to go over it. There's a couple of options in there, but for the most part, you can choose the defaults, get it installed. It loads a special software driver that sits between your network interface and the operating system, and it's called a PCAP driver, and that's what's going to go ahead and allow for your data to be captured. Okay, let's start and take a look at the interface, the screen itself. Across the top, you have your standard Windows menus and things like that. Lots of different features, lots of options in here. Again, this is a very basic introduction to Wireshark, so I'm not going to get into much detail here. The top section here with the white bar, this is your filter bar. Basically, Wireshark has so much data coming in and out of it, you need a way to filter through it. And this command line up here allows you to run some pretty intense filtering schemes, and that'll help you narrow down the data you're looking for. If you're looking for a TCP string, you're looking for a DNS query, whatever it might be, you can find it using the filter. There's a huge library of filters available. There's a lot of resources available on how to do filtering. That's kind of the heart and soul of Wireshark. So we're not going to get into too much, but just know that that's there. The big colorful section here in the top middle is the packets themselves. It's going to start, when you start up Wireshark, it's going to start from packet 1 times 0. All your captures, all your packet numbering, and your times are relative to the start of that capture. So if I start a new capture, it's going to start over at packet 1 times 0. So just keep that in mind when you're trying. If you have a couple different packet captures you're looking at and you notice the time, it's got to be relative to that particular file. Okay, so in the middle here, so after you have your number, your time, and then you're going to have your source and destination IPs. That's really simple. That's the packets. That's where the packet came from, or at least it says it came from, and that's where it was destined for. So it's either on these packet captures, it's either going to be coming from my machine, going somewhere, or coming from somewhere, going to my machine. Again, because I don't have promiscuous mode, I'm just seeing traffic destined for my machine. Then you have the protocol. Obviously, that's just going to tell you the different, what kind of packet it is, what kind of data it might contain. The length is the size in bytes, and then the info is kind of a summary about that packet. It just gives you some basic, 30,000 foot view of what that packet's about. All right, they're color coded. It's all automatic. You can set them, but the defaults are good, and it's going to color code based on the type of information it is. You might see a red one if it's a bad packet. Different packets are going to have different colors. It helps you visualize it quicker. Okay, then as we come on down here, let's see here. Bring this up here. In the middle here, this white area, this is basically your the data, the very specific data about the packet. This is your OSI layers. You remember, if we go back to that, we have the frames. Move this down a little bit here. The frames. This is the base of the packet. This is basically how the packet moves across the wired network. Now, there's not much information here from a forensic or an investigator's point of view, but if you're a network engineer wondering why traffic is not making it to a certain destination, or why things are getting malformed, or something like that, you might be able to capture information within the frame that's helpful to you. Again, a low level thing you wouldn't really worry about. Then of course you have your Ethernet layer, your IP layers. Okay, these are moving up the stack. Some are going to show you how the data is routed across the network. Some is going to show you how it's routed across the internet, right? So this information is very detailed. It takes the zeros and ones that make up a packet and break them up to their respective sections, as explained in the protocols white paper. So again, not much information here right now. We're going to use it gets super technical. I'm not going to go into it very much. What we're usually looking for is the bottom part here, which is the actual, this is it. This is the data. Okay. This is the payload. This is what's in there. That's what's being sent. Again, packets are only small segments of data. So the packet is definitely part of a bigger stream. And that's what we're going to take a look at now. Let's take a look at one packet here. This is a TCP packet. Try and find one that maybe has some plain text in it. I'm not sure if we're going to find that. I'll explain what I mean by that in a second. No big deal. So let's just right click on this packet. If we take a look at it, here's the data for that packet. Doesn't mean anything to you. But if we right click it and go to follow, whoops, I'm sorry, that was the wrong packet. This is the packet right here. Right click on that packet, go to follow, and follow the stream. You're going to see what looks like an obvious mess. Now, what you're seeing here is all the packets, all the packets part of that specific payloads, all brought back together. You can see there's a lot more data in here. There's a lot of different things, but it looks like it's a mess only because it's encrypted. I'm on a VPN. Most web pages today are going to be encrypted. So the data isn't of any value like this. And again, this is why we recommend that you use some sort of VPN to encrypt your data, because if you are that hacker in Starbucks, this is all they're going to be able to see. Okay, so this specific data is safe, it's protected, it's encrypted. All right, I'm going to close this down. We'll look at some other ones that makes a little more sense. But you'll notice when I clicked on it, when I right-clicked it and said follow stream, it created a filter automatically, and it basically said TCP.stream EQ, which means equals 13. So that packet was part of stream number 13, whatever that is, and I basically told Wireshark to filter out everything you have except for stream 13. And this here, if you notice here, there's not much now in here. This is all the packet traffic related to that one particular set of data. All right, I'm going to go ahead and clear this out. Hit the X. And this brings us back to our live stream. This is all the data, again, unfiltered. This button up here is kind of the most important one. So right now it doesn't look like much is happening, even though the packets are still flowing in. Nothing's changing. I can scroll up and down with the wheel on my mouse, but other than that, I don't see anything. And that's because we've paused the live stream. It's still coming in. I hit this button up here and I jump down to the bottom, and now I'm seeing all the traffic coming in live again. Okay, that's how we follow a stream. And that's how we follow the live traffic that's coming in. Okay, I'm gonna go ahead and stop it again. And that button here. Let's take a look at something else here. I'm going to take a non-encrypted packet. So something like, I don't know, maybe a UDP packet, which is, all right, let's go ahead and follow that stream. There it is. Now, again, what this means is kind of irrelevant to me. It's got my computer name in there. So it's some sort of, it's broadcasting something about my computer name. It's passing some data along. No idea what it is. It's a pretty big packet here. I'm see if there's anything in here of worthwhile, and I don't really see anything. So whatever it was, whatever's broadcasting, it was broadcasting the name of my machine over and over with some sort of identifier. Not sure what that's about. And here again, we've limited it to UDP stream 0. So I'm going to go ahead and clear that one out now. See if we can't find something that's a little bit more interesting. All right, DNS, here we go. So at some point, my computer needed to look up something about Microsoft Office, probably because it's running in the background. So let's go ahead and follow this stream. Nothing much in here, but basically, here you go. It's Office 365 was contacted. It got the DNS request in and out, and this is the data that was recorded. And as an investigator, it might be important to you for something, but this is how you would find it. This is how you would locate it. Okay, some sort of, it was an A record lookup in a DNS. Basically, it was looking for an IP address. That's all that is there. All right, clear that out. I'm going to go ahead and just give you a quick demo of capturing something live right now. In my residence here, I happen to have a Google Mini, one of those little devices you can talk to, ask it questions, and it's like having a little friend in a box, right? So I'm going to ask it a question, and let's see if we don't see the data come across the network. Okay, Google, what time is it?
The time is 1:04.
All right, there it is. I asked it a question, and I did see this fly by, and there it is. I don't know how to read this because this is proprietary to Google system, but some sort of query did go out asking for Google to do whatever it does to go out and get the time. And I can go ahead and just pick one of those packets and follow it. And whatever it was doing, that's what it did. Okay, we can take a look at the data again and see what's going on, a little bit more of a reader usable format. Again, the request for Google probably came across a non-encrypted channel. The data coming back in was probably encrypted, so we're not going to see much there. But this whole conversation here is part of the request I just made to get the data. So that's a real quick overview of what Wireshark does. Go in, play with it, download it. It's free. Read some resources, watch some YouTube videos if you're into networking and capturing intrusions on networks and things like that. Wireshark is something you're gonna need to know. That's it. One last thing. If I'm gonna go ahead and stop this complete capture, this just stops the scrolling. The red button stops the actual capture. I'm done. The capture's done. It's over. This file is going to contain 1,600 different packets. Oh, that's my bad. Look at that. I got a filter in there. Let's get rid of that filter. Okay. Actually, we're going to have 16,120 packets. 100% of them are being displayed. 0 were dropped, meaning that my computer, my network card was able to keep up with the flow of data. So that's a good thing. If I go ahead and restart the capture, this one's done. It's going to ask me if I want to save or continue without saving. Saving, you can save it as a PCAP file and you're all done. Okay, that's it. You can put the file away, archive it. That is a record of all the network traffic that happened during this presentation. That's it. Download it, play with it, enjoy it, have fun with it. It's free. All right, so that was the demo. I hope it makes sense to you. Hope you get a little bit out of that. It's something, again, download it, play with it. It's a great tool.